Now let's take a look at the example 2, also circuit A and B, two circuits, and respectively we're going to conduct both nodal and mesh, one method at a time as exercise. Okay. And again, equations only. We don't need to worry about the results. So first, circuit A. From circuit A, we can see that if we apply nodal first, we choose middle nodes like here as V1, here V2, here V3, and that's it. Because again, we don't like corner nodes here, we don't like corner nodes here, and we don't like the bottom super node ground either. So to middle 3 nodes, we are writing KCL at. Before that, we need to realize some very simple thing to make our rest of the analysis much easier. First, at node 1, what is the voltage of node 1, V1? It equals to 12 volts. Why is that? Look at the original circuit. V1 is here with respect to the ground is nothing but 12 volts, given by this voltage source. For the same reason, the voltage at node 3, V3 here, is equals to -6 rather than +6, because the positive polarity is the ground, negative polarity is at V3. So if you're fully aware of two node voltages, then the rest of the KCL equations are easier. Let's take a look at the node 1. 3 equations involved. By assume the current direction like these, we can come up with first equation like this. A little bit tricky thing is this current here, which is the current here, this branch, going through 12 volts voltage source. Like we have said several times before, to a voltage source, we don't know the current through it. So to write this KCL, we need current. And how to have this current out of voltage source? The answer is no way. So we have to assume this current as an unknown, inevitably. By the way, we don't have a resistor series connected with this 12 volts voltage source either we can utilize. Therefore, we have to assume it is as I sub 12 volts. So this current is leaving the node 1 plus this current here, also leaving the node. We are using V1 minus V3, which is 12 minus -6, divided by the resistance 1 kilo ohm in the middle, and plus the last current, which is from V1 flowing towards V2. So V1 is 12 minus V2, divided by the resistance 2 kilo ohm in the middle here. So sum of them equals 0. KCL at node 1. Next, let's talk about the KCL at node 2 here. First of all, this current has been obtained from previous equation here, so we just copy it here. It is entering node 2 current. It is equals to the sum of two currents leaving it. So the current flows through this 1 kilo ohm downwards here is equals to V2 minus 0 divided by 1 kilo ohm in the middle. And the third current here from V2 to V3, we are using V2 minus V3 divided by resistance in the middle. No, because there's no resistance in the middle. Instead, we only have a voltage source. So how to take care of this? We have mentioned for here, we have to assume another unknown to represent the current flows through this voltage source, because no way to know this current. KCL at node V3. Again, 3 currents. This current has been taken care by previous equation. This current has been taken care by previous equation as well. So the only left current is here, which is again the current flows through a single voltage source without any resistor series connected with it. So we have to assume a current unknown, I sub 6 volts. According to the assumed current direction, we have this current plus this current equals to this current, I 6 volts. 3 nodal equations. If you count, you have 3 equations, no problem. However, how many unknowns? We have V2, I 12 volts, I 4 volts, and I 6 volts. So 4 unknowns. 3 equations, not sufficient. So we have to somehow figure out one more equation. So what equation we can figure out? Actually, we should be able to notice the difference between V2 and V3 is nothing but this 4 volt. So by reading the 4 volts polarity, we should say V2 go down by 4 volts equals to V3, or V3 go up by 4 volts equals to V2. Therefore, this is the equation. And of course, V3 equals to -6 volts here. We have figured. So now we have 4 equations and 4 unknowns. We can do the job. The last but not least, keep your mind focused on what is really asked for. In this particular example, is asking for I naught, not anything else. So by those 4 equations and involved unknowns, we have to come up with I naught. So I naught in this circuit is labeled in this direction, which is opposite to our I6 volt. Therefore, I naught equals to negative I6 volt. Now, same circuit, let's apply mesh. 3 meshes, obviously. I call this as 1 here, 2, and 3 here. So to mesh 1, we have current I1, mesh 2, current I2, and so on. To mesh 1, we have KVL like this. So we can tell easily 1 kilo ohm only has I1, introducing a voltage polarity like positive, negative. So it's positive 1K times I1. And then we have 4 volts source with negative here, positive here. So we are coming across negative first, and the positive follow. So it's negative 4 volt. Next is 2 kilo ohm here. This guy has 2 currents going through. One is towards left I1 and towards right I2. So we can write as 2K times I1 minus I2. Sum them up equals 0. Then mesh 2 KVL, we have 12 volts here, which is something couldn't be easier. According to this rotation direction, again, we will coming across negative first. Positive follow, therefore it's negative 12. And then negative here, positive here, so it's negative 2K times Y1 minus I2. Therefore it is equivalent to positive 2K times I2 minus I1. Last one is voltage across 1 kilo ohm here. So again 2 current with opposite direction. So it is 1 kilo ohm times I2 minus I3. Equals 0. Similarly, we have mesh 3. So 1 kilo ohm I2 minus I3 is negative, or you're writing like 1K times I3 minus I2, same thing. Positive, negative 4 volts here, 4 volts here. And then you have negative, positive 6 volts. Therefore, it's negative 6. Since by the rotation direction, you are coming across negative first, followed by positive polarity. 3 equations and 3 mesh currents as unknowns. We can find all of them. However, never forget our ultimate goal, which is I naught. So I naught in this circuit is clearly equals to the negative I3, since the direction is opposite. Now let's move on to example 2, circuit B. A similar problem. However, let's see what's the difference from circuit A. So by applying nodal first, we obviously choose V1 and V2 here, 2 nodes, with assumed voltage V1 and V2 respectively. Okay, to write KCLs for these 2 nodes, we can use the Ohm's law across a resistance. So at V1, we have assumed this current was this direction, and this direction. So this direction current is equals to the voltage at this node minus V1 and divide by 6 kilo ohm. However, what is the voltage at this node? The voltage at this node is nothing but 3 volts, because from this node with respect to the ground, and 3 volts voltage source is right between these two. So this node voltage is 3 volts. 3 minus V1 divided by 6 kilo ohm is equals to this current entering the node, equals to sum of 2 currents leaving it. Downward current here, V1 minus 0 divided by 12K. Towards right current, is a current going through a voltage source. Again, we have no way to know the current from a single voltage source, so we have to assume it is equals to I sub 6 volts. Node 2, we have this I 6 volts again equals to 2 currents leaving it. So downward current equals to V2 minus 0 divided by 6 kilo ohm, Ohm's law. And the current here equals to what? We do have a resistor here, series connected to voltage source. We are not relying on the voltage source to find the current value. So we are using the voltage V2 here minus the voltage here divided by the 12 kilo ohm in between to find the current. What is the voltage value of this node? It's equals to -3 this time. So V2 here minus -3 here divided by 12 kilo ohm is the current of this branch. So here is the KCL. So from these two equations we can count, we have V1 I 6 volts, V2 3 unknowns, however 2 equations. So we have to somehow figure out more equations, one more. Okay. And here I come up with this equation. So notice that the difference between V1 and V2 is nothing but 6 volts, established by that 6 volts voltage source. And by the polarity of which we can tell V2 go down by 6 volts equals to V1, or say V1 go up by 6 volts equals to V2. So now 3 equations and 3 unknowns. We can find all of them individually. Of course, never lose your focus on the things we really looking for, which is I naught in this circuit. I naught is here, which is equal to the V2 minus 0 divided by 6 kilo ohm in between, Ohm's law. So if the exam asking for a equations only answer, and here it is, up to 4 equations and 4 unknowns. And also make sure you're including the I naught as one of the unknowns. Now let's try the mesh. 3 meshes, 3 equations. So in mesh 1, I1, we have this equation. So clockwise rotating, you come across negative first, followed by positive here, therefore -3 volts. And then you keep rotating, you come across the voltage cross 6K. So due to I1, it is introducing a voltage with this polarity. So it's a positive 6K times I1. Next, we are coming across 12K resistor. And due to I1 and I2, you have 12K times I1 minus I2 with this polarity of the voltage cross equals 0. Loop 2 in the middle here. So we have same voltage here. However, because of this rotation direction, we come across negative polarity first, followed by positive. So negative 12K times I1 minus I2, equivalent to this 12K times I2 minus I1. And then negative positive for 6 volts, so -6. And then plus I2 minus I3 times 6 kilo ohm equals to 0. The last one is here. So you have 6K times I2 minus I3, however negative here, plus 12K times I3 with polarity like this, last minus 3 volts here equals 0. 3 equations, 3 unknowns, very good. And plus the final answer for I naught is equals to I2 minus I3. Be careful, the labeled I naught direction is downward, which is consistent with I2 rather than I3. Therefore, it is equals to I2 minus I3.